Hi, Enda.
Hi, Renee.
I'll start out the same way I've started all these out. Do you consider yourself to be a data scientist?
I guess I do.
All right. And we'll come back later to some of your career and to let the listeners know you've written a book called Guerrilla Analytics, and we'll come back to that later. But first, I want to kind of go back to your childhood. And was there anything early on that made you feel like you wanted to become an engineer or a data scientist, or you thought you would write a book? Any indications early on?
I guess not. I mean, I always liked language, so I always enjoyed writing things. In terms of data science, I mean, it didn't exist when I was growing up. I came into it via mechanical engineering, but I think it was pretty obvious early on in mechanical engineering that I was more into programming and data and experiments. So I wouldn't say early childhood, but university.
Were there programming classes in the schools growing up?
Not so much. It was just getting introduced actually in Ireland. So I think we did some basic stuff in secondary school, but it was only really in university where I encountered, I think it was Fortran 77 actually was my first programming language.
Okay, so did you have any role models in your early life that were engineers or programmers?
I guess coming from the engineering side, it would have been some of the traditional engineers. I think nowadays it's probably people like, Peter Norvig. He always has interesting blog posts. It's very nice, the combination, I think, between, the fact that he's obviously, very experienced, very advanced in his career, but still finds time to do a little bit of coding and to play around with problems via his blog. So, yeah, he's certainly a role model.
So did you take to programming right away, or was it difficult for you? How was that early learning phase?
I think I took to it right away. I think it was only one course for us in engineering, but I probably spent a disproportionate amount of time at it. And when I started working as an engineer, I seemed to always find opportunities to do things that involved some programming. So I guess I was always looking for it.
Okay. And did you start working right after your undergraduate degree? How did that go?
Yeah, I went straight into a consultancy that did simulation of mechanical engineering systems. So, simulation of parts for race cars, yachts, that kind of stuff. And I guess that, what that exposed me to was, analyses that are very computationally intensive and that generate a lot of data. So I guess that's where I started getting into data analysis.
So what were some of the early tools that you used in the analysis?
A lot of it would have been, they're quite specific niche engineering tools. There are maybe 2 or 3 main providers for that type of mechanical analysis and simulation software. But it was really my exposure to that led me to go back to university and to, I suppose, convert to computer science.
Okay, so you went back, and was that a master's or a PhD program that you started back in?
Went back to do a master's just to convert, and enjoyed what I was doing a lot, so ended up continuing and doing a PhD in the UK, and that's what brought me to the UK.
What university did you go to for that in the UK?
That was the University of York.
Okay. So is there anything else you want to say about your schooling, or anything that was particularly impactful up until this point, projects you worked on, or memories you have that you really look back on and realize that it highlighted your love of data?
I don't know if there's one distinct moment, but I think it's been an interesting journey. So, I mean, I began the PhD looking into genetic algorithms and similar things, but found, especially coming in from another discipline, from engineering, that I suppose the approach to analyzing and designing those algorithms was maybe not very rigorous in some ways. So the PhD itself ended up being about design of experiments and the statistical approaches you can use for, I suppose, basically determining if one algorithm is better than another and why it struggles on some data sets and not others. And I suppose that was really the start of my journey as a data scientist, and went from there through a variety of consultancies. So I suppose if there was ever a moment, one key moment was deciding to take my PhD thesis in that direction. And probably the next big moment was somewhere, where I landed in consultancies and was exposed to, real data science at pace, with all the complexities and dynamics involved in that.
Okay, so tell us more about your PhD thesis. What was the title of it? What did you find?
It's called Design of Experiments for Tuning Optimization Algorithms. And what I did was I explored using a set of techniques from a discipline called Design of Experiments to figure out what the right tuning settings were for a group of algorithms, particularly ant colony optimization algorithms.
Oh, wow. And what language were you programming in at that point?
At that point, I was doing a lot of just kind of bash scripting, and the core algorithm itself was written in Java. The analysis was more packaged statistical software. So I think it was called Design Expert and maybe a bit of SPSS as well. So it was still, I suppose, at that stage, it was more about the experiment design and the suite of algorithms rather than any particular data science coding.
Okay, so you transitioned from that into consulting, and I saw on your LinkedIn profile that you worked for some of the big consulting firms, Ernst & Young and KPMG and such. So take us through the consulting part of your career, and especially with getting those jobs. What was it like, being on the job market, and how did you, market yourself with your engineering and computer science background into these data consultancy type roles?
Sure. Actually, the first consultancy before the two of those was a smaller, more boutique consultancy, and they specialized in analytics amongst other things. So I suppose to some extent it was an easier sell. But I guess coming out of a PhD, you're always emphasizing, and I suppose these days I interview a lot of people who are PhDs as well, and I guess you always want to emphasize that, some of the really relevant things that come out of a PhD are things like the discipline and the tenacity to stick at a difficult problem, the ability to, refine and communicate a sometimes technically very deep idea, both in presentations and in written form. And the ability to, I suppose, lead yourself over an extended time period. So that kind of independent working. I remember that first interview had a presentation component as well. So that first consultancy, they were quite aware of the need to be able to communicate at the right level. And then, I can talk a bit more about the subsequent places as well, if you like.
Sure, go on.
So that first one with Detica was more, I suppose it was more a pre-sales role. So we were doing social network mining, I suppose around 2008. So Facebook was starting to become popular this side of the pond. And we were using social networks for fraud at the time. So a lot of the work revolved around that central data mining software, and you would have to do a lot of the data preparation and data modeling to produce networks that would identify fraud. The big four work, Ernst & Young, KPMG, forensics, that was more less centered on pre-sales software, more about completely ad hoc analytics jobs for forensics. So if, for example, there was an allegation of fraud or bankruptcy, corruption, then you would be brought in to gather the right data, put it together in new ways, and generally help support auditors, forensic accountants, and so on. Check for a smoking gun, I guess.
And what was the learning process like for that? Did you pretty much just get thrown in and figure it out as you go?
Yeah, there's a lot of that. It's the first consultancy, Detica, had a training program of maybe 4 to 6 weeks at the time. And that was mostly around getting to know their software so that you could configure it and use it. A lot of the others, probably a bit more thrown in, which is really the best way to learn. I think in formal education, you can only do so much in terms of learning a language, making yourself aware of the techniques and so on. But there's no substitute really for real client data and real client pressures and requirements, I guess.
So what else happened in your career before you decided to write a book?
I think the book was a culmination of a lot of very dynamic, very fast-paced and pressured projects. And I suppose I was at a point where I'd seen a good few of them and was kind of thinking about, well, what is it that makes these projects so difficult? And what could you do to make them a bit easier, a bit smoother? And I suppose when I was thinking about it, a lot of it is to do with the fact that, kind of data is unknown, or you're joining it together in ways that hasn't been done before. Requirements change as you discover and learn about the data with your client. And you're working in a bigger team with a variety of experiences. So that can lead to things being quite complex and quite chaotic, and that actually prevents you doing the really high value work. So I think it was just a series of project work over the years that led me to write the book and say, look, there are some common things, and if we do these things on projects, it just makes the whole data science and data analytics process so much smoother, and you can actually buy yourself the time to do the high quality work.
Yeah, definitely. And as I was reading the book, and thank you for sending it to me, by the way, it reminded me a lot. I mean, right now I'm a data analyst working with fundraising and alumni data. And we have a lot of the same thing where we might be diving into a part of the database we've never worked with before, or working with people on campus that we've never worked with before, or bringing in data from another system. And it is a little bit chaotic. And even if you seem to have a process, we've tried to nail down our approach and how to record what we've done so it's reproducible. But as I was reading your book, I was reminded a lot of how messy it sometimes can be. And I think that this will be valuable to talk about on this podcast for people becoming a data scientist, because the earlier you can learn these techniques and put them into practice, the better.
Yeah, and I think it's you can look across it and you can see bits of, well, version control that would be second nature to a software developer, and refining your data in clear stages from raw to kind of any advanced variables you might want to use. That would be second nature to maybe an ETL developer or a warehouse person. But I think data science is a funny game that it needs to bring together aspects of many different fields to get the work done. So yeah, hopefully the book is useful for people to have a kind of single point of reference for, I suppose, the operational aspects of doing data science, less than the machine learning and visualization side, the kind of foundation operations you need to follow to try and keep things a bit under control.
Yeah, and what's an example from your career of a team makeup? Like, I know in data science sometimes there's engineers and analysts and people from different business backgrounds. So give an example of a team that you've worked on and who was on it.
Gosh, there's probably nothing typical. I've managed teams of just two of us, and teams of up to 15. And I think if there's anything that's common across them, it's just the variety. So it's been software developers transitioning, it's been seasoned statisticians, pure mathematicians, even chemistry graduates. So it's been all sorts, really.
Yeah, definitely. Okay, so let's look at the book now. This is Guerrilla Analytics. It's called A Practical Approach to Working with Data, The Savvy Manager's Guide by Enda Ridge. And it was very readable. It's very accessible to beginners. It's not a lot of tech speak. It definitely goes into the process and the background of approaching working with data. So in the beginning, you talk about the difference between a data factory and a data lab. So give us an example of a data factory and a data lab, and why you said that a lot of work seems to fall in between those two.
Yeah, it's I think that was a metaphor I borrowed from, maybe it was a Harvard Business Review article. I forget the citation will be there, but I guess I was trying to capture this idea of, the difference between, you can think of a spectrum from, let's call it data science, through to some kind of development of a data product. And I guess the difference is that at one end of that spectrum, at the data science end, it's very exploratory. You mightn't even know what the right question to ask is. And so the nature of the work is, is there an algorithm for this? Can we segment customers in this way? Is there enough wealth in the data to do this kind of analysis? And so the kind of, I suppose the competencies and the technologies you use at that end of the spectrum can be quite different to the factory side, which is more about fast, regular production of well-known data, an agreed algorithm, And it's all about testing and quality, and I suppose it's just a different kind of emphasis, really, if that makes sense.
And do you find that the people with a computer programming background and the engineering background tend to lean towards the data factory approach and want something, repeatable and put in production and to scale?
I think it's probably more a personality thing, really. I think
Okay.
some people prefer, extremely structured, regimented designs. Other people like to just dive in and play around with the data. And if there's anything coming out of the Guerrilla Analytics book, it's that you need to take the best of both worlds, really, because data science without any kind of process is complete chaos. And yet, writing a detailed spec and designing your data flows before you know there's any value in the data can be a waste of time.
So does this book kind of serve as a communication tool between the different personalities on the team then?
I didn't get into personalities too much, but I hope it's a sufficiently lightweight set of rules of thumbs. It's not prescriptive, like you say, about any particular technology. It doesn't need to be. But I hope it's just some lightweight rules of thumb that get the best of both worlds, and hopefully any mix of a team can kind of gravitate around it and use it.
Yeah, so I'm going to read a section here where you're describing that in-between type of project. So you say, however, there's a large class of projects where some of the expectations of both the factory and the lab are present. These projects may have many of the characteristics of the lab in that the data is not understood and must be explored. They also have many of the requirements of a factory in terms of repeatable and tested analyses that can be easily rolled out to end users. The project environment is extremely dynamic in terms of available resources, both people and technology, changing requirements, and changing data. In these scenarios, the data lab approach begins to fail. Teams with a range of skill sets and experiences are sharing code and data. There's no longer an individual data scientist coding analytics in isolation. The advanced analytics toolkits may not be available if the team is located on the customer's site. Clean data is not immediately identifiable or available for experimentation, and the data keeps changing. Every experiment performed may be subject to external scrutiny and test. Every experiment performed may need to be explained to a customer in the context of previous experiment results. And in these scenarios, the data factory begins to struggle. There's no time for detailed data modeling, specifications, and requirements. Any requirements that do exist will probably change frequently. Helpful engineering tools such as test frameworks and refactoring methods may not be available or may never be made available in a project with short timescales. There is little role division. Every team member has to be able to contribute to a bit of everything. These projects are best described with phrases like extremely agile, highly dynamic, having many disruptions. These projects are where you need guerrilla analytics. And for people that haven't worked in the data world yet, I will confirm that this is exactly how things look.
I'm glad you said that, because it was sounding quite scary as you read it back to me.
So tell us how you came up with that name, Guerrilla Analytics, then.
I actually owe it to a good friend of mine. So we spoke about this kind of stuff at a conference together, probably back in 2012. And, he was coming from a research academic background and, just curious about data science and what it was all about. And I think he coined the name once I described those kind of characteristics to him. I think it's a good one because, guerrilla kind of warfare is about small, non-conventional, I suppose, armed forces rather than a large conventional regimented army.
Yeah, definitely. So let me read through some of the principles of guerrilla analytics that you have in chapter 3. And you can tell us a little bit, expand on some of these, because I'll just read the headers here. So principle 1, space is cheap and confusion is expensive.
Sure. It's a weird one, that, and a lot of these sound, I guess, common sense, but I've been on so many projects where people, immediately start changing the raw data they receive, or they fail to archive and keep stuff for the duration of a project. And I suppose these days there's no reason to do that, really. Space genuinely is cheap. And what does cause confusion and chaos is when you don't know whether data you're looking at is data you created or whether it's the pristine raw data you were given by a customer. And again, losing track of that wastes your time and actually just also makes you look bad with your customer.
Yeah, and it's definitely a great idea to always keep a copy of that original data file, because if you have to go back to the customer for it, that, like you said, that makes you look bad. But also you can always compare what you have now and make sure you didn't drop any rows or anything.
Well, and that point is the critical one, Renee. There's kind of a I don't know, is it called Snakes and Ladders, that game in the US where you go across
Sheets
the
and ladders here.
Okay. And the process is very like that. And if you find there's a mistake in your report and you go back to your code and your code is good, and you go back to your ETL and that's good, you go all the way back and you might find that actually the mistake was in the raw data all along. So having that raw data available is critical.
Yeah, definitely. Okay, so principle 2 is prefer simple visual project structures over heavily documented and project-specific rules.
Right. So I guess this one came about because I'd been in the situation where we've all been confronted with these dynamic projects, and one reaction is to start listing out a set of rules. So, we'll have like a folder structure we'll have a folder for SQL, we'll have a folder for Python, we'll have all these sets of rules about our variables and so on. And it actually has the opposite effect. It's so complex that it constrains the team, it slows them down, it confuses them, and people nearly become paralyzed. So while you do need some conventions, try to keep them as simple as possible. And if they're visual, so if you can see from looking at a project structure, what each component is about, then that makes it much easier because you don't have to document it. It's obvious from the layout of the project or the naming of your project and your code and your data sets.
Yeah, that makes a lot of sense. And definitely in these creative, fast-paced environments, like you said, just structure can stifle everything if it's too overbearing.
Yeah.
Okay, principle 3, prefer automation with program code over manual graphical methods.
Yeah, this is kind of one where, a lot of technologies out there, quite popular technologies, they have a GUI, a graphical interface, and you have to point and click to configure them and effectively do your coding. And I suppose to some extent, Excel is one of those. So you create a formula by dragging those cells. And the challenge with that is it's not reproducible. So when I look at a completed spreadsheet or I look at a completed dashboard, let's say, I have no idea how that it was created. I have no idea about the journey the data went through. I have no idea what was original data and what stuff that I created. So the best way to completely describe what you've done to the data is program code, because if you've written it well, it's perfectly reproducible. So this principle is simply saying, try to do as much through program code as possible, even if it's simply importing your data for analysis, because that way, if you need to redo it, you can redo it at a click. If you need to rerun your 50 code files, well, it's very simple to iterate over them in code and execute them all.
So do you think the more recent tools like R Markdown and Jupyter Notebooks are really good for this because you can put the code right next to the output?
Yeah, I think so. I'm just starting to use Jupyter Notebooks. I would have, I suppose, until recently had individual script files and used build tools like Ant to automate across them. I think, yeah, you're right. The nice thing about Jupyter is you can interleave your notes and your thinking with the actual code, which is a little neater than just, asking people to comment everything.
Yeah, definitely. Okay, principle 4 is maintain a link between the data on the file system, data in the analytics environment, and data in the work products.
Yeah, I guess this is just another way of saying maintain data provenance. Know where stuff came from, know what you did to it, and know which bits of that you sent to whom. Again, the reason for that is a typical workflow that you follow is that some data lands, you have to do a little bit of prep to get it into your chosen analytics environment. Once it's in there, you do all sorts of iterations. And at the end, you'll send some report or some aspect of a report to somebody. And the more you can trace that lineage, that provenance, the easier your job will be. Because what very often happens is you do some analysis, you create a presentation, and somebody drills into it. They say, well, what is that number? Where did that come from? And if you can't go away and figure that out quite easily, then again, you start to look bad and trust in you is diminished.
And I like one of the suggestions you gave in the book, which was if you're using a product where you can't easily comment in line, that just find a way to tag it, like add a comment, for instance, in a Word document, and just comment where that came from anytime you add a number.
It's yeah, that one requires a bit of discipline. I guess it is a big one. You know, we still use PowerPoint and Word for the vast majority of our presentation, and it is hard to trace where did you cut and paste that from. I think things like Jupyter will make it easier, but maybe just, yeah, a simple hidden note saying this was work product 52 might make your life a lot easier too.
Yeah, definitely. Okay, principle 5, and you said this one comes naturally to software engineers, version control changes to data and program code.
Yeah, so this is simply, so version control is a technology or an approach for tracking every change to your program code and who made it. Now, you don't need a version control system to do that, but it makes it a lot easier. And certainly what you don't want to do is, in a very iterative data science environment project, it's typically very iterative. You need to track, you need to freeze at points in time, you know, the code that was used at each of those iterative deliverables. Version control makes that very easy. So have some way of version controlling the code in your project.
Oh, and another thing I wanted to mention, which I guess goes back to principle 4 about maintaining a link in the data, is something you iterate several times throughout the book, mentioned several times, which is that the underlying data is always changing. You could pull some data out of a production system, and by the end of the day, the underlying system is already different. And we experience that a lot here where, you know, somebody will make a pledge to make a gift, and then, you know, they either don't pay the pledge or the pledge changes, the value changes. And so even if we go back and run the same query for the same past data, even that past data has changed.
Yeah. And I mean, you can think about ways to get around that. You might, rather than just selecting latest data, you might select a set of IDs so that you could always go back and get those IDs easily. But yeah, it's a real concern. If the goalposts are moving, it makes your life very difficult.
Yeah, definitely. Okay, principle 6 is consolidate team knowledge in version controlled builds. This might be called institutional knowledge.
Yeah, so as you go through a project, you start developing or discovering business rules, let's call them. So how you should join the data together, what certain fields mean. And without some central institutional knowledge, a couple of things can happen. First of all, as an individual data scientist, you lose track of all these changing rules because, you know, it's not uncommon where you go back to your business customer or the system SME and they say, oh yeah, it's that field with these codings means the following. And actually a week later you discover, oh, I found 2 more codings. What do they mean? Oh, right, yeah, now that I see those, I remember whatever. So everyone's understanding is iterating. And I guess, if you're not keeping track of that in some way, you can get confused, which is bad enough. But if there are several of you on a project, you can start presenting inconsistent interpretations back to the customer. And that's a really bad place to be because now 1 week's analysis is completely inconsistent with the previous week's analysis. So I suppose this is an example of one where warehouse people would say, well, you're just building up fact tables of the data. And it's like, yeah, probably we are, but make sure you do that. Make sure that those common core tables like customer name and address are put in one central place where the whole team can feed off them.
And you also mentioned in one of the stories in the book, for people that haven't seen the book, there are a bunch of little example stories where there will be somebody going through some process and realizing why they need Guerrilla Analytics, basically. But one of them is, yeah, one of them, and I remember the name because it's my sister's name, was a woman named Andrea that was going through a bunch of addresses. And the question was, at what point in her analysis did she join the addresses together, and were they uppercase or lowercase, and that prevent some of the joins? And I go through that. So we have a magazine that we send out from James Madison University, and I'm the one that pulls the labels for it. And I don't think people understand how complex the process is of going from addresses that are from several different systems on campus or the National Change of Address database, and then going through the process of coming to a consistent label and merging by household if you can combine people living together and things like that. So I appreciated that story.
Yeah, it came out of a very similar experience I had myself with, again, trying to tie down, how many addresses had a customer had, what's the latest and greatest one, and, whether it's right or wrong, this is the one central consistent approach, and then we can pick away and iterate at it. But if everyone's doing it differently, you'll never get anywhere.
Yeah, and I think a lot of data scientists lament on how much time is spent cleaning data, but that's really a big chunk before you can analyze anything. You got to know what you have and know it's in the right format.
Yeah, it's inevitable.
Okay, and the last principle, principle 7, prefer analytics code that runs from start to finish.
Yeah, this is nearly, I say this one at talks I give sometimes, and you can tell by the reaction, the backgrounds of people in the audience. It would be difficult to write software product code that didn't run or didn't compile, right? Because you'd never get to check it into the repository. But the nature of analytics is that you end up writing loads of code snippets. You end up jumping between maybe some SQL, some Python, some R. And the problem with that is you then get to a point where you say, right, my work is done here. Let me hand it to a colleague to review. And because of all those snippets, some of which are now broken because of the iteration through the data and code, nothing really runs anymore. And you end up in this ridiculous situation of, oh yeah, don't use that bit of code anymore. Just skip to the next one. And yeah, it's time consuming, it's frustrating. And so you really need to have that discipline that when you know what your final analysis is, make sure that you can just click go in your language or tool of choice, and that whole analysis will start at the start, run through and finish at the end. It makes debugging, it makes review, it makes code quality much better for the sake of a simple bit of discipline like that.
And what is your response when people say, well, that last step just takes too much time. I have customers waiting for the data. I got to turn it over. And I have 4 more analyses on my do list for today.
I find the turning point with that one is when you introduce peer review in a team. Then everyone.
And so explain to people what peer review is for people that aren't familiar.
Oh, sure. Peer review is simply the process of any kind of coding is complex. Having a second person look at it and critique it helps find errors, but also helps you grow, because that person might say, well, here's a different way of approaching that problem, or here's another aspect of your language that would have made this easier to analyze. So, peer review where the first half of the peer review session involves the person saying, oh, wait, no, I forgot. No, it's not that code. Skip that file. Go over here. Mm-hmm. Not a very satisfying process.
So have you ever been on a team that didn't use peer review and you had to initiate that, and how did that go?
Yeah, most of the teams, to be honest. It's like any kind of people change. You need to explain why it's happening. You need to tell people how it's going to work. Let them feed into that process. And I suppose, like many things, there's resistance at the start. But I think in general, if it's done in a constructive way, people understand that it improves the quality, and people understand that it's a great opportunity to learn from the other people in the team and improve themselves.
Okay, great. So you have a section toward the back of the book that says Guerrilla Analytics Skills, and I'm going to read through these and let me know what it's like interviewing people that you want to bring onto a team that's going to use these practices, and what are the particular things you look for. So here's a list of skills: hacking or programming, substantive expertise, math and statistics knowledge, communication, visualization, software engineering, the data environment, mindset. So tell us a little more about those and what you look for when you're hiring.
I think a lot of them, so I'm actually hiring at the moment, so this is topical. Maybe people will watch this. I've taken the approach where I kind of test for all of those things through scenarios, generally real scenarios that I've encountered. So, in terms of hacking or coding, you need to know that somebody's relatively proficient in a language. And there's no better way to test that, I think, than asking them to code something. So I do give homework to people on real data that's been anonymized. Communication, obviously critical. So, the ability to raise your analysis and results to a variety of levels so that your audience gets the message, because that's all that matters. They're generally not going to appreciate that your model accuracy is 74%. What they'll appreciate is that if this model were applied to the business problem, the value would be the following. So communication is obviously critical, but it's also critical within the team. If you're one of those people who won't do a peer review or do it constructively, then you're going to be problematic in a team. What else did we have in there? So familiar with the kind of data environment. So, are you able to look at data, interrogate it, recognize a lot of the common issues, like missing values, profile your data, just the kind of general data gymnastics that allow you to move around a data set and reshape it in lots of ways. It's not so critical, that one, so long as you learn it. But the better you are at it, the less time you spend doing it, and the more time you spend on the real added value.
And you had visualization in there. How does visualization weigh against the other, like math and statistics and programming?
It would be hard to do the visualizations without some of the programming skills. I would say visualization is probably right up there with the maths and stats. If you can't, because it's critical to communicating those results, it's critical to data exploration, so getting a good handle on what's going on in the data. So I think there's probably only 9 or 10 core visualizations you need. Being able to do them in your language of choice, I think, is really important, and knowing when to use them. So are you trying to visualize something over time? Are you trying to visualize different proportions in categories? And Nathan Yaw's book is very good at outlining that, I think.
And what did you mean by the last one, mindset?
So mindset is, we spent a lot of the interview, I guess, talking about the difficulties of the data science environment. And you'll often find that some people are just discouraged by that. The dynamics, the change, put them off. And so a critical part of that mindset is tenacity, so the ability to keep going despite those disruptions. Certainly curiosity. So if you do see an outlier in your data, do you want to pursue it? Do you want to know what it is that's weird about it? If you're asked to do one type of analysis, do you deliver that and another type because the other type also turns out that it might be relevant? So those kind of qualities, I think, are really important and probably aren't emphasized enough when people talk about the skills of a data scientist.
Yeah, that's great. And curiosity and creativity seem to be a recurring theme in this podcast that comes up that people might not think about when they're first learning to be a data scientist.
And it's a hard one to, how do you foster or train creativity? I like the idea of a portfolio of projects, be that in your research or education or in your industry career. But the more projects you've seen, the more data sources you've seen, then the more you're going to recognize certain types of patterns and be able to get into the data quicker. Because, when data lands with you, it's like, where do you start? It's such an open exploratory problem.
Yeah, definitely. All right, well, we can wrap up here. And I want to say thank you for sharing this book with us. Again, I've been talking to Enda Ridge, and this is his book, Guerrilla Analytics, A Practical Approach to Working with Data, The Savvy Manager's Guide. And I will post the link in the show notes so you guys can find it. And do you have any last advice or wisdom you want to share, or something you wanted to highlight from your career, something that we didn't get to talk about?
I think, gosh, there's so many things, but I think, if you're thinking of getting into data science and wondering where to start, just get stuck in. There's so many great, online courses out there, so many great books. Get some real data and start working a problem. It's fun. It's like a jigsaw puzzle. So rather than hovering over it and reading about it too much, get stuck in. It'll be a little frustrating at the start, but it's really rewarding, really interesting career to be involved in.
Yeah, definitely. Well, thank you so much for talking to me today, and I'm sure a lot of people will gain a lot from this interview and from your book. So thank you so much.
Thanks very much for the opportunity.
Okay, bye.
Bye.